Thank you for your patience. So what do I do? Good. So what is left? 10y minus 24. Excellent. Minus 5y equals negative 9. Do we all agree with that? Do we all agree that 12 over 1 times 5 over 6, do I have to show that? Are we okay with it? And then 12 times negative 2, and then negative 5y minus 9. Are we okay? Yes, Will? Are you okay? Okay, perfect. So now combine like terms. So I have 5y, and I move 24 to the other side. 24 minus 9 is? 15. Very good. It turns out that if it's correct or not, I don't know yet. But for now, y equals? 3. Very good. Now I have to go back here. Replace y by what I just found out. So then I have x equals 5 over 6. 5 over 6 over times 3 over 1 minus 2. So I simplify by 3, and I get x equals 5 halves minus 2. I find that the least common denominator is 2, and the top has to be multiplied by 2. So 5 minus 4. It turns out that x equals 1/2. Do we agree with 1/2? So it turns out that it appears to be, I should say, that the solution is 1/2 comma 3. I don't know for sure. I haven't checked. I can't be certain yet. So I go back to the original problem. So I'm going to copy it here. X equals 5 6th y minus 2. Don't trust anything. And again, you don't need me to tell you whether this is correct or not. Don't wait for me. I'm going to do my own calculations. So x appears to be 1/2, and this appears to be 3, and 1/2 and 3. So 12 times 1/2 is 6. 6 minus 15 is indeed negative 9. That's correct. And this one is just what I just determined. It's right here. So 1/2, and this is 5 over 2. 5 over 2 minus 4 over 2. Yes, it is 1/2. So I know for sure that this is the correct solution. No doubt. Any questions? Any questions? Yes, Becky, go ahead. It's not on what?
It's not on this.
It's not on the list?
No, it's not on this. Your question's not.
Oh, so which question it is? You're asking which question? I just picked one. I just picked a problem.
No, it's not on this.
She has a different question on a different subject.
Oh.
I was sitting like a look at you.
Oh, yeah, no. Any question? Oh, it's something else that you want to ask? I thought we were talking about this problem. That's why I didn't understand. I'm sorry. Yes, I'm ready. Okay, let's do that. Okay. In 8.1?
Yes.
Okay, so let's take a look. Twenty-three. Yes, it's the same thing we just talked about. So you're given the slope, which is 1/2, and a point which is negative 6, 2. So you have to use y minus y1 equals the slope times x minus x1. You plug in negative 6 here, 2 here, and 1/2 here. Yeah, we have to try to remember these three equations, the slope, definition, y equals mx plus b, and y minus y1 equals the slope times x minus x1. They're very, very useful. Very good. I'd like to present the adding method. Okay, so 4.3. The elimination, I think your book, it says addition, yes. So the addition method. In other books, it's called elimination. It's up to you how you want to call it. Okay, let's talk about this for a second. I hope you agree that every equation is a balance, right? The left-hand side equals the right-hand side. So what I have here, even if they look totally differently, at the end of the day, the left-hand side equals the right-hand side. Okay, so here's a question. So I have two equal weight markers. One represents the left-hand side of the equation, the other one the right-hand side. And I decide to add a marker here and the same type of marker, same weight on the other side. Did I destroy the balance?
No.
No, because I added the same quantity on one side and the same quantity on the other, right? I did not destroy the balance. This is the idea of the adding method. So we are going to manipulate the equations somehow, but at the end of the day, we will add to one side the same thing, but they will look differently, but we're going to add the same weight to both sides. That's the idea behind the adding method. So there are, of course, different difficulty levels. In one situation, which is the easiest, is this. Page 270, problem 11. So x plus y equals 6, x minus y equals 6. This is the easiest possible type of system, really. I don't have to do anything other than just remember, I am allowed, these two are equal. These two are equal. Because they are equal, I'm allowed to add this here, and I'm allowed to add this here, because they are equal. So this quantity is added here, this quantity is added here. Why? Because these two are equal. So all I have to do is draw a line and add. And I get 2x. This goes away, and I get 12. X plus x will become 2x. Y minus y is definitely 0. And 6 plus 6 is 12. I eliminated by adding the equations, because I'm adding the same quantity to both sides. And I got x. How much? X is 6. So now I go back anywhere I want. It doesn't matter. And I determine y. How much is y? Exactly. The prospect solution appears to be, I'm not sure yet. I haven't checked. The prospect solution appears to be 6, 0. I don't know. It could be. Now I'm checking. 6, 0, 6, 0. Is 6 plus 0, 6? Is 6 minus 0, 6? It means that this is the only solution and no one can find another. Which case is this? Case 1, case 2, case 3. Case 1. Independent equations, consistent system, unique solution. Consistent system, independent equations, unique solution. Perfect. So this was the easiest type. Okay, here's the next level. Yes?
Is all the variables 0? Like when they're by themselves, so like the x and the y are always going to be 0?
No.
Okay.
No.
Okay.
This is just a simple case in which it happened that one of them is 0. No.
Okay.
Nope. Okay, here is the next type. Problem 9. Next level. X plus 5y equals 18. 3x plus 2y equals negative 11. Do not write this. I just want to make a point. Okay? No, my next step. My next step. Write the system down, but not the next step that I'm going to do. This will not help. I'm not eliminating anything. So by simply adding the equations, this piece here and this piece here, because they are the same, is not going to help. So I have to perform an operation before I add. So I'm going to copy the system one more time because I messed it up. And now I'm going to ask you, which variable do you think we should eliminate? If I try to eliminate y, exactly, you're right. If I try to eliminate y, it will be more complicated because I have to multiply this by a quantity, the entire equation, and something here needs to be multiplied because otherwise how will I get to get 0 here? Only if this is positive 10 and this is negative 10 or vice versa, which means I have to multiply both equations. However, x is much easier. I will only have to multiply one of the two equations. Which one and by what? I think the sun is gone, so I can move this. Absolutely. I will multiply the first equation, both sides, of course, everything by -3. I'm allowed to do that. I will not change the solution. So negative 3x minus 15y equals negative, but I have 18. Did I copy something wrong? I thought I had 8. That's okay. That's okay. Now I copy the second equation, 3x plus 2y equals negative 11. And yes, now I can add. It's going to be fine. I hope you agree. I met my target. X will go away. So by adding, these two go away. I have negative 13y, and I have negative 63, negative 65. What do I do next?
Divided by -13.
Right. So then x equals 5. Is this enough? It's good, but it's not good enough. What do I need to do next? Yes. I have to go back, plug it in. Oh, I'm sorry. This was y. I'm sorry.
Okay.
I wrote y, x instead of y. I'm sorry. So I have to go back here. Not there. So then I have x plus 25. So x plus 25 equals 18. So x equals negative 7. So it appears, we don't know yet because we haven't checked, it appears that the solution is good. So I have to go back. I don't trust this. I can easily make mistakes. So negative 7, 5. Negative 7, 5. Negative 7, 5. So negative 7 plus 25 is 18. Yes, that is true. Negative 21 plus 10 is negative 11. That is true as well. So I know that this is it. Consistent system, I checked. Consistent system, independent equations, unique solution. This was level 2. Level 1 was just add and I get rid of one variable. Level 2 was it needed some work. One of the two equations needed to be multiplied by blah, blah, blah. Now what do you think is level 3? Of course. Both equations need adjusting. Yes. Okay, so let's take a look on the same page, page 270. Problem 22. Okay, 22. Where are you, 22? Okay, so negative 2x plus 3y equals 10, and 3x plus 4y equals 2. Here is how I make my decision. I look at x, and I see negative 2 and 3. The simple fact that one has negative and one has positive is attractive to me. Why? Because I don't have to multiply any of the two by a negative number. Because I know myself, most of the time I know myself, and I may make a mistake when I multiply by a negative number. It doesn't matter, really. which one I choose to eliminate. But it's safer for me if I don't have to multiply by a negative number. Who knows what I'm going to come up with? That's one thought. Then I look at 3 and 4. I see both positive. I would like to eliminate x. If I decide to eliminate x, I have to find the similar to the least common denominator. So if I have 1/2 in a denominator and 1/3 in another, then I know that the least common denominator or the least common multiple, if you don't want to think in terms of fractions, I know what do I have to obtain here and here. What do I have to obtain is the least common denominator. What is it? 6. So therefore, I know what I need to multiply both equations by. What will I multiply the top one by? Exactly. What will I multiply? So I can get this -6. What will I multiply the bottom one by? Exactly, so I can get the +6. So when I multiply the top by 3, I get -6x plus 9y equals 30. If you omit to multiply all terms, you are changing the problem, and you're not going to solve. Then I multiply by 2, so I have 6x plus 8y equals 4. Now I like it. Why? Because at this stage, what will I do? Simply add them up. So 17y equals 34, so I have y. How much is y? 2. Do we all agree with 2? Okay, perfect. Now I go back to the original problem somewhere. It doesn't matter. Let's say I'm going, of course. Sorry. So I go back to y to determine x. So -2x plus 6 equals 10. I will have to move 6. And x appears to be -2. So I have no idea if this is true or not. I don't trust it. So I'm going back to the original problem. And I replace -2, 2, -2, 2. Let's see. -2 times -2 is +4. And this is +6. 4 plus 6 is 10. Yes. -6 plus 8. 8 minus 6 is 2. Yes. So I'm going to say yes. Consistent system, independent equations. What else? Unique solution. These are all possible levels, but I also would like you to choose a problem with fractions, like 37, 38, or 51, 52, 53, 54. Please choose one with fractions so we can use what knowledge we have now about systems in solving word problems. You trust me to choose? Thank you for your vote of confidence. So I will then choose 52. 52 has x plus 1/3 y equals 5 divided by 12, and 8x plus 3y equals 4. We're going to get it started. We're going to eliminate fractions, and then I'll let you work on it for a minute. The second equation is the second equation. I don't want to change anything here. It's okay. But the first one has fractions in it. I refuse to work with fractions. So I will have to do what first? By. Very good. So then the first equation becomes 12x plus. Can anyone give us the second term? 4y. Very good. And can anyone give us the last term? 5, right? Perfect. So then 8x plus 3y equals 4. Make a decision. Eliminate one of the variables by the adding method if you want. And then we'll work on it together. 1 minute. Okay, 2 minutes. And I will put my attendance in the meantime. Of course, I'm logged out. This is here, David is not. Will is here. Joe's here, Norman. Tori is here, Daniel is here, Mike is here, Matt is here, Jackie is here, Abby, Yella, Brenda, Matt, Peter, and Riley is not. Perfect. Raise your hand if you need help. I'll be right there. Let me know if you need help. Do we need more time? Is it done? Okay. Oops, I only have 10 minutes left. I don't know why I thought we'd go longer. Okay, so can anyone give us an idea how to approach this? Yes, please.
Multiply the top line and integrate the bottom line.
Excellent. Perfect. So negative 36x minus 12y equals negative 15. And 32x plus 12y equals 16. Excellent. Which variable are we really eliminating then? Exactly. So gone. So negative 4x equals 1. So x equals negative 1/4. Is that okay? Excellent. So now I go back. Where do I go back? It doesn't matter. So let's say I'm going back here. So I have a times negative 1/4, which is negative 2, plus 3y equals 4. So 3y equals 6, y equals 2. It appears, I'm not sure yet, it appears that we have negative 1/4 comma 2. Question mark, I don't know, haven't checked yet. So I have to go back to the original problem. I'm going to copy it here. X plus 1/3 y equals 5/12, and 8x plus 3y equals 4. So I'm checking the first one, which is negative 1/4 and 2, negative 1/4 and 2. The second one is easier. A times negative 1/4, this is negative 2, and this is plus 6, and that is indeed 4. This is done. Now I'm checking this one. Negative 1/4 plus 2/3. I need to find the least common denominator, which is 12. This has to be multiplied by 3, and this has to be multiplied by 4. Negative 3 plus 8. Yes, the answer is 5/12, which is this. And I would say absolutely yes. And that's the only solution. So as I said, we have 9 minutes left. I would like to start on one problem. If we finish it, we finish. If not, I'll stop in 9 minutes. And this is the last section of chapter 4 that we have to look at. There are a lot of different problems. All this section 4.5 are word problems that all convert into systems. That's all. And we just have to solve the system. So on page 42. Sounds nice. 42 on page 294. So this is section 4.5 applications. Okay, 42. Let's read it, even if we just come up with a system and then we can solve the system at home. A charity fundraiser consisted of a spaghetti supper where a total of, I take notes as I read, where a total of 387 people were fed. I don't like to say were fed, I would have said were invited. They charged $6.80 for adults. $6.80 for each adult. And half price for children. What does that mean? Very good. $3.40 for children, for each child. If they took in a total of amount of $2,444.60, total, 2,444.60. That's what they, at the end of the day, that's what they counted their money and that's what they got in. Find how many adults and how many children attended the supper. I will read the problem one more time, at least one more time, till I understand what it's given and what I'm asked to do. 387 people were invited. Each adult paid $6.80. Each child paid $3.40. At the end of the night, we counted the money and we got this. How many children and how many adults were invited? First, I have to ask myself, how many variables does the problem have? Yes, 2. I have to name them. So I will give them 2 names. So let's say, what is X? Number of adults. Perfect. And what is Y? Since the problem has 2 variables, how many equations do we have to write? Absolutely. 1 for each variable. So please think for a moment and give me 2 equations. The equations have to be consistent. People plus people equals people. Dollars plus dollars equals dollars. I cannot say dollars plus people equals something. So I'm ready when you are.
X plus Y equals 387.
Do we all agree with x plus y equals 387? The number of adults plus the number of kids. Good. Excellent. Perfect. Thank you, Mike. Second equation.
$6.80 X plus $3.40 equals $2,444.60.
Perfect. Dollars coming from adults plus dollars coming from children equals the total amount of dollars collected at the end of the day. Do we agree with both equations? Okay. Here is, again, I have 5 minutes. I'll stop in 5 minutes. So here is what I would do. I will leave this equation alone, but I will definitely multiply both sides of this equation so I can get rid of decimal numbers. What will I multiply by both sides? What is sufficient? I can multiply by 1,000, but I wouldn't. What will I multiply by enough to get rid of decimal numbers? Too much, because actually the last 0 doesn't count. Exactly, just 10. So now the first equation is x plus y equals 387. The second equation is 68x plus 34y equals 24446. Careful, we have to multiply everything. And now I will make a decision. I can use substitution. Nobody indicates to me what I should do. I can use substitution. I can use elimination. You decide. If you ask me, I will use elimination as many times as possible, as often as possible. Because plugging it in and distributing, for me, is more difficult. So if I multiply both sides by whatever you tell me, then I will eliminate the corresponding variable. What I would like to multiply both sides by? And you have to say either, if you go along with my suggestion, you have to say either negative 68 or you say negative 34. There is nothing else. If you say negative 34, then we will eliminate y. If you say negative 68, then we will eliminate x. It's up to you. It doesn't make any difference. I would do that too, because it's the smallest number. So then the first equation becomes negative 34x, negative 34y equals negative. Let me multiply these two. I'm lazy right now. So we have 34 times 34 times 387. I got 13158. Correct me if I'm wrong. And then 68x plus 34y equals 24446. I add, and the number of kids is gone for now. And then I'm left with 34x equals and I got 11288. Is that correct?
Yes.
Thank you very much. And then I will divide both sides, this number by 34. And I got 332. Well, I know that the sum has to be 387. So then I know what y is. 387 minus 332 must be 55. So it appears that the solution is this. What is the only thing I need to do now? Yes. And again, you don't need me to tell you whether it's true or false. And I don't need you to tell me whether it's true or false. I go back, 332.55, 332.55, and please tell me if this is correct.